Hello, everyone. This week we will review Chapter 4 of Essentials of Psychology, Concepts and Applications, Consciousness. Okay, so by the end of this chapter, I hope you are able to provide a definition of consciousness and correctly identify and describe the different states of consciousness. You will be able to explain how the sleep cycle is regulated and influences our daily life. Additionally, you will describe the characteristics of each stage of sleep as well as the brainwave patterns associated with each stage. You will also be able to explain why we sleep in the first place. You are expected to explain why we dream, be able to evaluate the effects of sleep deprivation. Then you should be able to identify and describe the different types of sleep-wake disorders. You will define and describe meditation and hypnosis. Then, demonstrate your understanding of hypnosis by identifying and describing the two major contemporary theories involved. As we near the end of the chapter, you will understand the differences between physiological and psychological dependence and between drug abuse and drug dependence. Hopefully, you'll identify various types of drugs and explain how they affect us. You will learn to explain the developmental process of alcohol and drug abuse problems in terms of psychological, biological, and sociocultural factors. Finally, you will demonstrate an awareness of the various treatment programs to help people with drug problems. So, with that being said, let's get started. All right, so now we're going to look at the states of consciousness. In psychology, focused awareness is a state of heightened alertness in which one is wholly absorbed in a task. It is a state of being fully alert and deeply immersed in a specific task, such as solving a complex puzzle, painting a masterpiece, or even engaging in a deep conversation. We achieve focused awareness through meditation, which involves focusing our attention on one thing, such as our breath, a mantra, or a feeling. The goal is to let our thoughts drift by instead of holding on to them. We begin by defining consciousness. It is the individual awareness of your unique thoughts, memories, feelings, sensations, and environments. Essentially, consciousness is your awareness of yourself and the world around you. This consciousness plays a crucial role in your decision-making process, as it is the platform on which you weigh your options and make choices. It's important to remember that your consciousness is uniquely yours. It's a deeply personal and subjective experience shaped by your thoughts, feelings, and memories. If you can articulate what you're experiencing in words, it's part of your consciousness. This individuality is what makes your consciousness so unique and worthy of exploration. Consciousness is a dynamic and ever-changing landscape. Your conscious experiences are in a constant state of flux. For instance, you might be thoroughly engrossed in reading an article at one moment, only to find your consciousness shifting to a past conversation with a coworker, the discomfort of your chair, or the anticipation of planning dinner. This fluidity is what makes consciousness so fascinating and complex. So, right now, do you find yourself thinking about something more interesting than this lecture? Perhaps a vacation you're planning, or a movie you recently watched? Well, I hope not. But drifting consciousness is the reason if you do. When our mind wanders, you can consider this a state of drifting consciousness, where our mind drifts or wanders from what you might be doing at the time. As you may know, it can be hard to maintain a state of focused awareness for an extended period. After a while, your mind may start drifting from thought to thought. As you experience drifting consciousness, you may start daydreaming. According to Smallwood and Company in 2015 and Wang and Company in 2018, daydreaming is a form of consciousness that happens during a waking state, where your mind diverges off task to a realm of dreamy thoughts, fantasies, or distracting stimuli. This understanding is based on scientific research which helps us to better comprehend this phenomenon. Daydreams typically involve the mundane aspects of everyday life. Despite popular belief, relatively few involve sexual or romantic adventures. We looked into drifting consciousness. Now let us review divided consciousness. Divided consciousness happens when we simultaneously perform two different activities, each demanding some level of attention. One of these activities is typically a mechanical task, such as driving or washing dishes. When we perform mechanical tasks, part of our mind seems to be on automatic pilot, while the other part is free to think about different things. In the reading, catching a fly ball was an example of a more complex but still automatic behavior. This skill requires the brain to apply complicated geometric rules on the fly to determine a ball's likely trajectory and landing point in mid-flight. The brain automatically performs the mental computations needed to determine the ball's trajectory, even if the player does not understand the underlying geometry. Divided attention also contributes to inattentional blindness, the failure to notice something right in front of your eyes because your attention is directed elsewhere. For example, as discussed in Chapter 3, viewers of a video clip failed to notice the dancing gorilla among a group of basketball players when their attention was directed to counting the passes among the players on one of the teams. Now that we've finished discussing the different states of consciousness, let's ever wonder about sleep and what maintains it? Well, the answer is your circadian rhythm. The circadian rhythm is the natural 24-hour cycle of physical, mental, and behavioral changes in living organisms. We possess an internal biological clock in the brain's hypothalamus that controls our rhythms. Your circadian rhythm, a daily cycle of your body's mental, physical, and behavioral processes, is a marvel of nature. It's your body clock, governing bodily processes such as sleep, heart rate, blood pressure, body temperature, digestion, and hormone production. Understanding its significance can enlighten you about your body's intricate workings. Each circadian rhythm cycle lasts between 23.5 and 24.5 hours, or approximately 1 day. The frequency and duration of one's circadian rhythm tune primarily depends on the presence of light. Our circadian rhythm regulates many bodily processes, including sleep-wake cycles, temperature, hormonal secretions, blood pressure, and heart rate. The suprachiasmatic nucleus, SCN, a bilateral structure in the anterior part of the hypothalamus, is the undisputed hero of the circadian timing system. It is the central pacemaker, regulating most circadian rhythms in the body. Knowing its pivotal role can help you learn more about your body's inner workings. Circadian rhythm sleep disorders, also known as sleep-wake cycle disorders, can be a real challenge. They occur when a mismatch between the internal circadian rhythm and the external environment makes it hard to get adequate, restful sleep. Understanding their impact can foster empathy and understanding for those who struggle with these disorders. Several years ago, I had the pleasure of living in Alaska for work. One of the many adjustments I had to make to living in Alaska compared to the lower 48 states was the time difference. In Mississippi, we are on Central Standard Time. Alaska has its own time zone, 3 hours earlier than Mississippi. It always took me some time to adjust when I would return to Mississippi for a visit. I suffered from a severe case of jet lag. I would struggle with staying awake, often feeling grumpy and disoriented. It took a day or two to think straight. I always tried to include extra days for this alone. Jet lag is a maladjustment of circadian rhythms, the natural internal processes that regulate the sleep-wake cycle and repeat roughly every 24 hours. It results from traveling through several time zones in a short time. Rest, work, eating, body temperature, and adrenocortical secretion cycles may require several days to adjust to local time. Let's delve into the fascinating world of sleep stages. Psychologists investigate the mysteries of sleep using a powerful tool, an electroencephalograph or EEG. If you're unfamiliar with this device, an EEG measures the electrical activity in the brain like a window into the brain's inner workings. The test involves attaching small metal discs called electrodes to the scalp. These electrodes pick up the electrical impulses that brain cells use to communicate, and this activity is then translated into wavy lines on an EEG recording. An EEG is a simple yet effective procedure. It involves placing small electrodes on the scalp. These electrodes detect and amplify the electrical signals from the brain, which are then displayed on a computer screen as a series of waves. The EEG tracks brain waves, which vary in intensity or amplitude, height of the wave, and speed or frequency, wave cycles per second. When awake and alert, fast, low amplitude beta waves dominate your brainwave pattern. You enter a relaxed wakefulness as you close your eyes and relax in bed. In this state, slower rhythmic cycles called alpha waves dominate your brainwave pattern. When people sleep, the EEG shows they progress through several distinct stages of sleep characterized by different brainwave patterns. Understanding these stages is crucial for appreciating the importance of a good night's sleep. Stage 1 sleep is the initial stage of non-rapid eye movement, non-REM sleep, which is characterized by low amplitude brain waves, 4 to 6 hertz, of irregular frequency, a slow heart rate, and reduced muscle tension. Non-REM sleep, which encompasses the first 3 stages of sleep, is a crucial part of our sleep cycle. It is characterized by thought-like mental activity and little to no eye movement. There are 4 stages of sleep. The first 3 stages are part of non-REM sleep, and the 4th stage is REM sleep, during which rapid eye movement occurs. We spend approximately 75% to 80% of our sleep on non-REM sleep. The first full non-REM sleep cycle is typically shorter, lasting around 70 to 100 minutes. Subsequent cycles, which are remarkably consistent, last around 90 to 120 minutes. Most people go through 4 to 6 sleep cycles each night. Those who do not might have a sleep disorder. Another term used to describe stages 3 and 4 is delta waves. This chart provides a visual cue to the brain wave patterns and how they vary by sleep stage. Again, this is measured using an electroencephalograph, EEG. During the wake stage, you can see that the alpha and beta waves are predominant. In stage 1, theta waves gradually replace the alpha waves, marking the transition from wakefulness to sleep. Now, in stage 2, the theta waves, sleep spindles, and K complexes are predominant. Sleep spindles are rapid bursts of high-frequency brain waves that may be important for learning and memory. K complexes are high-amplitude patterns of brain activity that may occur in response to environmental stimuli. During stage 3, delta waves are predominant. This stage is also known as slow wave sleep. During REM sleep, your brain waves mirror those during wakefulness, indicating an active brain state during dreaming. These sleep cycles, which alternate between non-REM and REM sleep, are not just a natural part of our nightly routine. They also play a crucial role in our cognitive functions, particularly learning and memory. Understanding and appreciating this can help us prioritize our sleep for optimal brain function. So, our ultimate question is, why do we need to sleep? Without sleep, our health and well-being are at risk. How we feel while awake will depend on whether we get to sleep and what happens while we are sleeping. As we sleep, our body works to support healthy brain function and maintain our physical health. Sleep helps us to grow. In children and teens, sleep also helps support growth and development. Sleep would range between 9 to 12 hours per cycle as an infant. Getting inadequate sleep over time can raise your risk for chronic long-term health problems. It can also affect how well you think, react, work, learn, and get along with others. We learned that sleep affects your heart and circulatory system, metabolism, respiratory system, and immune system, as well as enough sleep. As we age, the amount of sleep and the length of the sleep cycles will lessen. I mentioned how sleep helps with growth. It reminds me of my youngest son's experience. Early in adolescence, my son's height was stunted. He stood approximately 4 feet 10 inches. However, my son only slept 4 to 5 hours each night. I explained that if he slept through the night like his older brothers, he would grow like they did. Initially, he was skeptical of my instruction, but he took my advice. Thankfully, in 2 years, he grew from 4'10" to 6'2". True story. Sleep's restorative function is to repair and replenish the body and brain, allowing you to function well during the day. The optimal amount of restorative sleep is about 40 to 50% of the total time asleep. You can improve your restorative sleep by not drinking caffeine late in the day. Try not to take too many naps in the afternoon. Reduce the number of hours spent on screen time, which includes computers, smartphones, and television. Implement more exposure to natural light patterns. If you can reduce exposure to bright lights, disruptive noises, and distractions from technology before bedtime, you may improve your sleep. Also, try not to stress yourself out at bedtime. Last but not least, get regular exercise throughout the day. Your ability to stay mobile will increase the restorative process when you sleep. A dream is a product of our brain's imagination during sleep. It takes us on a nightly adventure into a fantasy world. Dreams that visit us later in the night are longer and more elaborate, leaving a more profound emotional imprint. But the question remains, why do we dream? The answer, like sleep, is not straightforward and likely involves multiple functions. Dreams, it seems, are not just flights of fancy. A leading dream investigator, Ernest Hartman, suggests that dreams serve a practical purpose. They help us sort through possible solutions to everyday problems and concerns, and even work through emotional crises or traumas. This view is consistent with the content of many dreams, which often involve difficulties encountered while trying to perform a task. Could your next big idea be brewing in your dreams? Another prominent view of dreaming, the activation synthesis hypothesis, holds that dreams represent an attempt by the cerebral cortex to make sense of random discharges of electrical activity in the brain during REM sleep. Electrical activity arises from the brainstem, the part of the brain responsible for such essential functions as breathing and heart rate. According to this hypothesis, the cerebral cortex creates a storyline based on the individual's storehouse of knowledge and memories to explain these random signals emanating from lower brain structures and the emotions and sensory experiences they generate. Sleep deprivation, when an individual does not get enough sleep to maintain optimal health and functioning, can have serious consequences. It occurs when a person receives less than the recommended amount of sleep, typically 7 to 8 hours per night for adults. Sleep deprivation can result from various factors, including lifestyle habits, work schedules, medical conditions, and environmental disturbances. It can adversely affect cognitive function, mood, physical health, and overall well-being, highlighting the need to address any sleep issues promptly. Sleep deprivation is a condition where a person gets insufficient amount of sleep. There are several reasons for this occurrence. It may result from illness, shift work, or lifestyle considerations, such as having a newborn and staying up late to study. It also induces responses for experimental or interrogation purposes. Studies show that losing one night's sleep substantially affects physical or mental functioning. Participants score significantly lower on judgment and simple reaction time tests and show impairments in daytime alertness and memory. Sleep loss also may be detrimental to the immune and endocrine systems. Drowsy driving, a preventable tragedy, claims lives every day. The key lies in prioritizing stress-free and ample sleep. Research indicates that most drowsy driving accidents occur in the early hours. Fatigue takes a heavy toll on the American public's safety, health, and quality of life. The consequences are equally dire, whether it's due to sleep deprivation from a newborn, a late or extended work shift, late night socializing, or a long, monotonous holiday drive. These include impaired cognition and performance, motor vehicle accidents, workplace mishaps, and health issues. Addressing these challenges can be daunting when our lifestyle doesn't align with preventing drowsy driving. In a 24/7 society where work, longer commutes, and rapid technological advancements take precedence, many people struggle to get the sleep they need. Effectively combating the drowsy driving problem demands significant shifts in societal norms, particularly attitudes towards drowsy driving. Now, let us discuss sleep-wake disorders, a prevalent issue affecting millions worldwide. For instance, maintaining a regular sleep schedule, avoiding caffeine and electronic devices before bedtime, and practicing relaxation techniques can help manage insomnia. Next, we have narcolepsy, a disorder that demands our attention due to its potential dangers. It's characterized by excessive daytime sleepiness and sudden attacks of sleep, which can occur at any time, even during activities like driving, posing serious risks. These attacks are often accompanied by hallucinations, sleep paralysis, and cataplexy, and involve an immediate entry into REM sleep without the usual initial stages. Lastly, sleep apnea is a condition that underscores the importance of early detection and treatment. It involves temporary cessation of breathing while asleep, either due to a blocked airway, obstructive sleep apnea, or a failure of the brain's respiratory centers, central sleep apnea. Left untreated, it can lead to severe daytime sleepiness and potentially serious health issues like high blood pressure, stroke, and heart attack. I want to mention two other disorders you should be aware of. Nightmare disorder is a sleep disorder characterized by repeated occurrences of extended, well-remembered dysphoric dreams, often involving themes of threat, that result in awakening from sleep in significant distress and impairment. It was formerly known as a dream anxiety disorder. According to the American Psychological Association in 2023, sleepwalking is a sleep disorder characterized by persistent incidents of complex motor activity during slow-wave non-REM sleep. These remarkably intricate episodes typically occur during the first hours of sleep and involve getting out of bed and walking. However, the individual may also perform more complicated tasks like eating, talking, or operating machinery. While in this state, the individual stares blankly, is essentially unresponsive, and can be awakened only with great difficulty. They do not remember the episode upon waking. Okay, so I will end this video lecture here. Please continue with your reading and assignments. Also, keep an eye out for future videos in Chapter 4. Part 2 will cover altering consciousness through meditation, hypnosis, and drugs' impact on consciousness. Also, do not hesitate to contact me via the inbox on Canvas with any questions. I will be happy to assist you. Until next time, thanks for listening.